5 root 2, like all of that over 2, or does that be plus?
True.
Can you just do that?
Interesting. No, good point. If I did that, I'd have to put this in parentheses to make sure that you knew that this part was being multiplied by the I.
I didn't do the I.
No, the I makes it very different.
Oh, I see what you did there.
Yeah. I combined the reals and I combined the unreals and I left them in this form. Okay, so that's addition and subtraction. Basically, you do it the same way you did in Algebra 2.
How do you know which ones are I's and which ones aren't?
They have, with the cis, when you convert it from polar to rectangular here, guys, when you convert it from polar to rectangular here, the real part is always 5 times the cosine of this angle, and the complex part is always 5 times the sine of this angle times I.
Like the Y.
Yeah. Yes. Except it's a one-dimensional construct.
Right.
2 lines. But yeah, it's like the Y. I'm with. We're there. Okay. All right. All right. So.
You got your back home, girl.
Now.
So many things to say.
Okay.
Sam.
Yeah, Sam.
She can't think on that. She doesn't really have so many things to say.
You don't have a soul.
Multiplication.
Like what you threw.
Okay, guys. Shh. Multiplication. I don't know how well you remember this from Algebra 2, but multiplication, if the complex numbers had both components, was annoying because you'd have to FOIL.
Wait, Mr. Dovo?
Yeah.
Back at this one over here.
Yeah.
Why is there suddenly a 5 root 2 on that side?
Because I added these components together.
Oh, right.
I'm bored.
Okay.
Film.
All right. I'm not going to do the same problem twice because that would be annoying. But in order to multiply before, if I had 5, shh, guys, minus 3i times 1 plus 2i. Multiplication the way it used to be, you had to FOIL from here, and you had to keep track of your i's squared. So my first would get me 5, correct?
Yeah.
And my outer would get me plus 10i, correct?
That didn't work.
Wait, can you slow down for a second?
Oh, but then it's I squared and that equals
1.
1.
Stop. Slow down, guys. Okay. Have I got the first right?
I got it, never mind.
I've got the first, and then I've got the outer.
So you're foiling this?
Hey, guys. Focus. Yes, and now the inner is minus 3i, and the last is minus 6i squared. Okay? Is this correct? Have I FOILed correctly?
Yes, it's just foiling.
Okay, now this is 5 minus, plus, 7i.
Wait.
I squared, if you remember.
Oh, look, 1.
Nope.
It's negative 1.
Negative 1. I is the square root of negative 1.
I knew that.
Okay, good. I squared is negative 1. So, this is minus 6 times negative 1, which is the same as plus 6. This is 11 plus 7i. You guys remember that?
Yes.
Good times.
I'm not going to do that.
Now, remember yesterday when I told you where this came from, where the whole idea of the imaginary plane came from, with thinking of the number line in terms of angles, in terms of direction, instead of the positive or negative. So this is our rectangular. In polar, let's say I'm going to pick a different example, because it's kind of a pain if I do the same.
Never mind.
In polar, what if I want to multiply 3 cis 45 times 2 cis 30? The rules I gave you yesterday for how numbers worked under that system where you use direction instead are the rules of the polar complex number system. So what you do is you multiply the numbers
And add the angles.
and you multiply the numbers, add the angles, and this is 6 cis 75.
Whoa.
So for multiplication, which is easier? Polar or
Polar.
rectangular?
Rectangular.
Really?
Yes.
Polar, I think, is much easier. Multiply 2 numbers, add 2 angles, boom, you've got an answer.
But then you have
Rectangular
to
isn't
use
bad either, though.
No, that's not bad. As long as you remember how to FOIL, you're in good shape.
Yeah.
That's so hard.
Where this really gets annoying is division, though.
Oh,
All right? So polar, like we discussed yesterday, you multiply the numbers, add the angles. It's the same as that system of numbers that I told you about, which is where polar comes from.
You know, that, when you
said the thing before
Uh-huh.
gets really bad when you talk about division, like, I expected there to be like a commercial.
And we'll be right back to talk about division after this word from our sponsors.
No, it zooms in on you, and then, like, that's where it ends.
That would be great.
It gets really bad.
All right, division. Division in rectangular. This is the one where there's like no real good way to do it, so you basically cheat.
Nice.
Huzzah.
I kind of admire the
multiplied
clever.
by the reciprocal.
Not the reciprocal, close.
No,
But the complex.
multiplicative inverse.
Slow down, Cowboy.
Same thing.
All right. If I have what's 5 minus 3i,
I can't see.
hang on, over 1 plus 2i. Here's the deal. What this is most like is rationalizing the denominator. The idea of division is you can't have a complex component denominator. You got to get rid of the complex component. But there's a rule you can use. It's this rule here. It's this idea that a plus b times a minus b equals a squared minus b squared. This factoring pattern is the key to division with rectangular complex numbers. So what I do to get rid of the unreal component in the denominator is I multiply the top and bottom of this fraction by 1 minus 2i. Where did I get 1 minus 2i from?
It's 1.
The bottom part.
It's the denominator with the sign in the middle changed. The bottom part, correct. Because according to this pattern, a plus b times a minus b equals a squared minus b squared. This is going to change my denominator
To a factor.
into 1 squared minus 2i squared. And when I square 2i, am I going to have any i's left on the bottom? No, I won't. The top, unfortunately, still has to be figured out by foiling. I'm not going to work out the foiling, but I'm going to continue to work out the bottom.
We just multiply it by 1 minus 2i.
Why did we?
No, why couldn't we just 1 minus 2i over 1?
Because you can only multiply something by a fraction that is equivalent to 1. We can't
Oh,
change the
yeah.
value of this, so it has to be the same top and bottom. Whatever we end up with has to have the same basic value as this division problem. So this is going to wind up... Johannes?
Yes. What?
Please be
Parker,
quiet.
pause it a second.